Okay, I think we are good to start. Hello and welcome again. And today we have introductory topic and a more discussion topic. I hope we will probably have this discussion about this topic. And me together with Emils, we will give us some our initial findings and understanding about data literacy. So we hear about data literacy that here and there. So we think that I would say that everyone I talk it with want to be a data literate. Uh, we, well, we assume that all of us are literate as we understanding it, like able read and write. But you will see that maybe we need also sometimes reconsider it. That really are we reading and writing as a literate persons? Because it's very important and a little bit different. And what we did for today, we gathered together different sources and opinions and views on data literacy. So yeah, let's go through. And starting data literacy with definition of it, and it is skill for how to read, work with, analyze, and arguing with data. So we understand that it is package of skills that we could read data, we could work with data, we could analyze data, and we could present. Basically, we could present the data. And what we found in a couple of sources that definitely data literacy is not equal to data science. So being data literate doesn't mean that you could do machine learning or advanced analytics or something like that. So it's definitely not it. But we will go and try to define and understand during this meetup what exactly is data literacy. I think it's a very important topic because we are living in the digitally driven or digital environment more and more. So there are more data available than ever, and each year we have even more data than probably in a whole our previous life. So it's we assume it's necessary to be data literate. It's something like, for me, it's something like in Middle Ages and in Renaissance and Enlightenment period to be a literate, that you could read. And if you are literate in the Renaissance, for example, then you could read the knowledge, you could acquire and get access to the knowledge of the antiquity, like read the Roman classics and Greek classics, so you could get to this knowledge. That is mean to be literate. And I would draw some parallels also with data literacy. And one of the important persons today for this story is Alberto Cairo. And we will give you some resources provided by Alberto Cairo. He's a data visualizer, so he's working with data. I would say one of the exemplar data literate persons. And he has this famous saying that one picture is better than 1,000 words. This part we know, but he added also the second part, if you know how to read it. So if you don't know how to read it or how to understand or what kind of data behind that, this picture not better than 1,000 words. And he's repeating it many times. So, and if we try to combine everything, so what the data literate person do, and if we pretend to be so, that it means that we have these qualities and we are using it in our everyday data analysis practice. So first is cultivate value of thought and reflection. So it's very important that we are thinking as some philosophers say, thinking about thinking. Philosophy is thinking about thinking. So we need to reflect on things we are doing, not coming to this like data literacy or literacy itself It's not that we are reading everything like Twitter, like short messages, or just when we are reading news, we are reading just titles and things that we understand what's inside. So reflection is compulsory. And second is read the paper books. We will come to it, but it's very important. That is why I put smiling here. So it's very important to read paper books. Ask questions, of course, to be curious. Discover meaning and things. So we need to discover, and of course, need to be curious and creative. So these are qualities of a data literate person. And this Kindle book versus paper book, it comes from Noam Chomsky. His interview said that when he's reading Kindle, then it seems like you are just going through pages, like you're just clicking and it goes through, and you forget what you read a couple moments ago. But when you read paper book, you understand where it's located. You are turning pages forward and backwards, so you understand where this knowledge is. And after all, I could agree that when you have this book in your bookshelf, you always remember what kind of contents somewhere was in this book, so you could take this book and find this. But in Kindle, it's really useful. I have some of Kindles. It's very useful. It's very fast. It's cheap. It's much cheaper. You could buy the books of fraction of the paper book. It's a fast delivery. It's yeah. It's even pleasure to read. But somehow the effect of it, it's much less. So I could also admit that effect from some meaningful reading of the paper book, yeah, is less than in this electronic device. Of course, still you could read it in more meaningfully, or also get a meaningful content in Kindle, but overall it's different. And here he also the saying I got from someone, I don't remember, that we need to not cover but discover. So all of the one of for me one of the main quality of the literate person and data literate person too is that you are discovering. You're trying to discover things everywhere. You're trying to discover why is this number so, where it comes from, etc., etc. And if we're going next step to understanding data literacy, of course, we also need to understand measurements and measures. And Emils on the second part will talk about measures more in a little bit more technical. And there is a very good book, I would say must read for any data enthusiast. It's a Douglas Hubbard book, How to Measure Anything. And it's a book about really how we perceive measurements and how we think about measurements. And he also introduced in this book concept which he calls COM. So concept, what measurement. But when we look at any data, for example, imagine you have a list of data and you have some transactions, some from eShop. Electronic shop. And when you look at this data, you need to understand what this measurement means. It is basket items. It's These are orders. These are late orders, new orders, last orders. So you need to ask this question conceptually: what measurement mean? And when you understand, it means this, then you go to next step and what we are actually measuring, what we are measuring, what is the object of this measurement. And the third is how we measure it. So how it's collected. It's directly from the eShop, it's export, it's some observations, etc. So it's very important. And that is where really data literacy starts, that we start to understand and analyze what is the data we are looking at? What is it? What's really it is? And depending on how deep you understand it, the better analysis you could make. Yeah. So it's very, very useful concept. And as I said, Emils will explain it even deeper, showing the different kind of data it have. And in this how to measure book, there is a very, very nice example of showing us that data, how we need to look at data, because understand that data is not something precise usually. That there's some noise and some shade in this data. So we don't work almost never we work with some very super precise data. And he present this Fermi problem, and after Italian scientist Enrico Fermi. And the question is, how many piano tuners are in Chicago? And it was a very famous question. And how to solve it if you don't know? Yeah, you could just look at the population in the city and how much people you have for per household. So you could calculate the households, and then you multiply by percentage of households with tuned pianos. So it's like 10 to 3% from 1 in 10 from 1 of 30. And then you need to understand how many tunings could be done during the year. And what you get an answer like between 20 and 200, and a fairly common answer, which is very close to what's really is 50. So what it means that sometimes we don't have all this data as a measurements, but we can do some assumptions of it. We could add additional data, and we need to understand what exactly of this, if we look at this flow of this equation, let's say, we need to understand which of the data we have. Do we have a percentage of households with tuned pianos? Do we have population? Or maybe we have something that help us to get to some of these numbers. So it's again and it's data literacy. It's again data literacy that we could say, okay, I don't know how many books we have, but I know how many pages average in a book are. Yeah. So it's very important to understand clearly what is the measurement we are working with and how it relates with other different things. And going further, for example, if we take such a simple business metric as profit, and if you look at this profit number, it's like we see that it's 451,000 US dollars. It means that it's amount of the profit. Yeah, of course we need. If you're looking just on this profit, we can't say much. We can't say really much. What we need data literate person will try to understand, is it good or bad, where it comes from, and what we will do with it. And if we look at this as number, we need to refer to, for example, the bullet points below. So we could say that goals. What was goal for this profit? And we could say that goal was $300. In this case, you will say, if we reached, we got more profit than we planned, so it's very good. But then, according exact hypotheses would ask you, but imagine that if we look at market conditions, the normal profit of company of your size last year was $1 million. So what do you say then? So you planned less, earned more, but could earn even more. So again, it's bad. So and so many different situations. And again, you need to look at the related measures. Maybe they could explain something more for you. Then you need to look at the context, year, country, region, products, etc. What's inside this profit. And of course, causality, like Judea Pearl, who is like most famous describer or evangelist of this of causality and the idea of causality and how to use it in relation to the data. We need to understand this causality. So what actually causes this level of profit? And there's another example, nice example from one of the Swiss pharma companies. An example is that um, one of the Swiss companies, for example, started to produce some pills twice as cheap as others, or 80% on the level, and it's according to old calculations, it's under the cost. So it's not possible to actually to get any profit by this price, but they getting profit, and then starting investigating this case, they found out that actually they are uh, providing less price because they're providing they producing it faster, so they're selling it faster because it's cheaper. They getting back money faster, so they don't need so much borrowed money. And on the financial services, like not using so much capital, so they could have capital turnover faster. So they are paying less banks, and that is how they earn money. So sometimes this profit even not coming from the core business, but from some business model. And let's look at these little couple, these the four skills more closer. And again, here is link in this QR code. You could scan it or copy it and then open. Behind this QR code, we have a link to a very good presentation of Alberto Cairo. I really encourage you to look it, so you will get pleasure and also very good understanding of modern data visualization and analysis with many examples. And at the end of the presentation, he's sharing readings, like books you could read, um, articles, and many more. So I will give you a link to all these resources also at the end of my part. So when we read data, so it's very important understand what we are reading and what we are looking at. And Alberto Cairo has a very interesting or very nice example. He's saying that we are nowadays we are trying to read fast. So we are fast readers. So we want really to acquire everything fast. So if it's slow, it's not interesting. So it's especially we see when you read something on internet, you see this 2-minute reading. Okay, I probably will read it, but if it's 10-minute reading, okay, come on, read yourself. So, and what Alberto Cairo says that it's dangerous. It's very dangerous. Why? Because we assume that what we assume. We assume the title say it all. So we look at title, we read title, like Twitter posts. So we look at the title and we decide read or not to read. We even decide what's inside. And we do it with news, we do it with longer articles. So and that is how we also consume information. So we want to get this aggregated version of everything. So something like in one line. And that is not data literacy. So if you're doing this is a very good example because it shows how the non-data literate person acts. So if you find yourself or you see that someone is doing like trying to consume these aggregated versions, it means it's not really, we can't talk about data literacy so much. And same with picture, yeah, or same with chart. We say this chart says everything. And Alberto Cairo saying that no chart says everything. And we need to go deeper, we need to discover, we need to understand, we need to reflect on it. So data literate person will not just read the titles, like 1,000 titles, but will go in couple of titles and go and read deeper and understand deeper, extract meaning. And of course, it's like dilemma, what to do in our turbulent times. Uh, should I read less but very, very carefully and deep, or should I read more? So it's of course very, very important question. And when we, let me see. Yeah, and it's a very important question. And here, like the interesting thing to remember is that your lifetime or our lifetime, like starting at 20 and ending with some 90 probably, we can read like 1,000 or maximally maybe 2 or 3,000 books. So that's our limit. But I would say that average person, like average meetup members will read 1,500 books, 1,500 books, 1,500 books. I mean, yeah. And imagine that you could read 1,500 books. So you need to choose wisely and very carefully. You need to select these books. And of course, if you read books about everything, you imagine that you will have one collection of knowledge and understanding about the world around us. If you will specialize in some one subject, and read this 1,000 or 2,000 books, you could become a really expert. So that is the same with data literacy. And there's a nice book, Data Literacy Fundamentals. And yeah, it gives some overview and some brief introduction in the topic. It's not very deep. But I took 8 questions from this book that when you work with data, you need to ask. And you could see these questions. I will not go through all of them, but the idea is the same. We discussed previously that it's very important to have your own framework. Like you can see that you inspect data, you discover, you try to understand meaning, you try to understand variables and how it's linked together, how it's collected, from where it comes from. Is it about this or that? So the the comprehensive understanding of data, so common sophisticated understanding. So that is actually data literacy. And data literacy therefore is how you interact with data. It's not that, yeah, I see graphs, or yes, I can read tables. No, it's how you look at this. And when in news you see the chart, what do you think? What is your first thought? So next time in the magazine or internet on TV, you will see the chart or data table. Try to remember this moment, that what what will be your first thought. Are you thinking about, oh, come on, it's twice as big as this? Or you will ask, okay, where the data come from? How it's related with the topic presented? Is it enough data? What is aggregation level? And things like that. Is there enough details? And on the analyzing side, we are trying to get insights and smarter decisions and visually encode information. And on the arguing side, there is one of the famous charts. It's from Alberto Cairo presentation, and you could see the three versions of these charts. And the first version is a Trump. It's a Trump. It's electoral election 2016 in elections, and it's Trump and Clinton and Hillary Clinton. And you could see that first is a Trump favorite map. So you can see that if you win in this county, so it's red. And then second map on the top is Hillary Clinton favorite map, and you could see also the population volumes of the bubbles. And the third is like compromise of it. So you could see that actual electoral voices, and you see the three different views, where more close to realistic or objective is the third map. Yeah, but still you could use data on different aggregation levels to show the data differently in these maps. Yeah, and this here we have useful resources. You could see the presentation, book recommendations, visualizations, and many papers. So you could grab this QR code and you will have this link published by Alberto Cairo himself. Yeah, I hope you did it if you want, or you could ask it in chat. I will post it in chat. And Alberto Cairo, in his presentation I showed on the second or third slide, he also introduces some principles, and he asked it on this presentation to spread these principles as much as possible to everyone. And here are these principles briefly. So actually what you need to ask and how you need to challenge any data and information. Yeah, and first, are we using, or someone is using the right data and showing the origin, that we could find the source or understand the source? Are we reading the graphic to match? So are we going so much in details, or we could understand it brief enough? Is it accurate data, or there is some combinations or aggregations that probably we could don't understand? Is this graphic showing appropriate amount of data? On what level or on what granularity we have this data? And in this point 4, we have this mapping example. And is uncertainty level relevant? So we understand that we are working with shady data, with fuzzy data. So how we show it? How we show this fuzziness? So are we saying it's approximately this or approximately that, or it's exactly this or that? So it's very important. Okay, that is like short introduction in the idea of concept of data literacy and what other people says about it. And now, Emils, please, can you share your part?
Yeah, good evening, everyone. So I'll put up my screen. Share. So, and all this gave a really great introduction on thinking about what is data. And in my part, I would like to share the knowledge that I have gained and I found out on the internet, what type of data we have and what you can do. Can give you a brief introduction. Just the closure, we are not talking about CSVs, JSONs, XMLs, SQLs, and you name it. We are talking about a more broader and fundamental classification. So, and first of all, what I wanted to start, I wanted to start with what Gartner is thinking about. What is data literacy? And Gartner is saying that it's ability to read, write, and communicate data in the context. So in this means you are providing the right information for the users, and with a specific context, not like giving some unnecessary data, but really something specific to make solution for specific problem. And the main objective of all that is to describe the use case, describe the application, and finally resulting in the value. And the value could be everything what company defines it. Also, not only the companies, also NGOs and like you power users. So this is like this Gartner definition, how they are thinking what is data literacy. Um, Also, yeah, Gartner is publishing a lot of great terminology, what they are saying, what is what. So if you are interested more, you can go to the Gartner page and see different words that they are describing. And what data types are? Uh, Basically, data types are usually not related to the tools or data formats, but they are fundamental, these measurement types. So, and with them, we are trying to explain some kind of specific tasks and problems. And it's interesting fact that data analysis is only the knowledge from the data. So we have the data, we measure it. First of all, we understand how to measure it. Then we generate the data, and finally we analyze the data using data analysis. And before, yeah, we look at this, we need to think what about or what and how we analyze these things, because I think this is the most important. In my experience, I've generated a lot of reports, and I can say honest that I'm just generating them and not thinking about why I'm doing this and then how to do it better. I'm just like doing this job, what I've been asked to me, and understood there's like the time when we need to step back to look at the big picture and understand why we are doing, why we are analyzing, and then how to improve it. And I will talk about these two big categories as quantitative and qualitative data. Probably you have heard this in universities and statistic courses when they talk about, yes, we have quantitative data and qualitative. This is really important because during this time we are doing the things automatically, and we need to, yeah, like as I said, uh, step back, see the big picture to understand, are we really collecting the right data? And then could we collect this data even better? And how to analyze it at the end. So let's go. First of all, the big group, quantitative data. What quantitative data are? These are the data which describe information that can be counted. It means it could be the weight, speed, length, what else? Sales amounts, stock indexes, logs in the cargoes, cargo ships, containers, you name it. Everything that can be counted. And commonly we know this is descriptive and textual information, and we can multiply it, subtract, add, and divide it. And here's like brief example to understand what quantitative data is. So I have like a small table with 4 clients and how many orders they have made, and we can see there's you can like count all these numbers. Under here, I have made an average of them. Um, you count them all together, sum it, and divide by the count of them, and you get the average. So you understand that the average order of these clients are X amount. And this is the thing we can do with the data. When we go deeper in quantitative data, we see we have this discrete data. And what discrete data is? This is the data that could not be divided in smaller parts or the fractions. We could not divide our employees into 2.5 employees or like 487.7 employees. We have like full numbers, full employees, yeah, for example. what else? Usually, like a logistic company sends a full container, not like the container is cut into half. Yeah, we have full containers, full ships, and these are the information that only can be discrete in one part big and could not be divided. And this is like the first type of quantitative. The second is continuous data, data that could be broken into smaller fractions. One example could be like the weight, 2.5 kilograms. Here I have the table with the flight numbers and the estimated time arrival of the plane. For example, 4 p.m. and 30 minutes. For 13 p.m., yeah, there's one type of the data. And it's all the time continuous. Why? Because it can be counted after the fractions and until it reached specific breakpoint. For example, we know in the time it's like 16, 59, and then go to the 0. In the kilograms we have like 99, and then go to the 100, and so on. This is like quantitative data. And if we look deeper in continuous data, then even we can divide this continuous data in two bigger parts. One of them is interval data. So this is the data. This is contains these nominal and ordered data, but the difference is that between these data points, it can be quantified. And what does it mean? This means that this interval date, for example, I have the price by year, and I can get quantified this price like in 2005 and then 2006, and the difference between the 2005 and 2006 is all the time 365 days. This means that like the difference between the two measures, two data points, is they are all the time equals. And this could be counted and subtracted, but not multiply or divide. I'll give you a brief example. For example, we have the temperature of, say, 20 degrees Celsius. And you could not get like 40 times 2, 20 times 2, 40 degrees. Yeah, it could not be possible. The temperature could not go so fast, and it's not even like possible to do that. So we can get only the 20 degrees, then 35, and then maybe 40, and you cannot like divide or multiply 20 by 2 and you get the 40 degrees. So and on all the time, the difference, yeah, between two in degrees is always the same. And for other categories, for example, here is price by year, and we know the difference between the years is always the same. And when you are thinking and building some interval data, it's really need to like take an account and remembering that the intervals between them is always fixed. And only what you can like do with this data is be counted, subtract, but not multiply or divide. So the second group is the ratio data. And with this, I mean that the data can be like divided by themselves. And in this data, it's really interesting that it has the true 0 point. And what does it mean? It means that the data, when the data has no value, for example, we have the weight. At the weight 0 kilograms, we have no weight. Yeah, it's not possible like to have. Or when the height is 0 centimeters, we know that it's nothing. So in the ratios, yeah, we have these 0 points. We need to like take an account, and we need to understand inside. For example, in the company, we have sales on Saturday 0. What does it mean? Is it good? Is it bad? Or that's it okay? Yeah, that we don't have any sales on Saturdays because like previously, if we go to the back in the intervals, we see, yeah, on Saturdays we are lacking of sales. And yeah, when you're using these ratio data and true 0 point, we need to like understand what does the measurement means. as all this already mentioned, yeah, you need to like ask yourself a question: is it good? Is it bad? What we can do about it, and so on. And usually, the data scientists can do the most of the work with the ratio data points because they are making different charts. For example, here is a rolling price average by years and months, and we can like make different calculations of them. And all these data could be divided in the 4 scales of measurement, which we'll go through. It's like different types of data which you can use, and how these like scales are built and scale. It's also divided by these two big types. One of the on one side is quantitative data, which I already showed you, and then there's the qualitative data, the nominal scale, and the order scale. And what's interesting of these 4 properties of these 4 scales are that all of them have some kind of identity. Each one have unique meaning. We know that this value means something and it's unique. We usually like transactions we have, and every transaction have unique ID. Then the second thing is the magnitude, yeah, the amount, and they have like some kind of relationship with other these values. Then of course the next one is equal intervals, and the data points between them are always in some kind of scale and are equal. For example, days, minutes, seconds, and finally, yeah, the point I already mentioned, to a minimum value point of 0, and the scale have true 0 point. This means that it's like some kind of like baseline benchmark when the things are like happening to the right side or the like not so well. And yeah, going through these values, we use scales, and we have this qualitative data, which means the data is not um, it's not numerical data. It's more like categorical, like text data. We have yes, no responses, some kind of like type of the segments of shops, shop names, and these are like this type of data which we could not like quantify by themselves. And the nominal data, it's defines the property of the data. It has no numerical meaning, as I mentioned. For example, we see this is the segment, and the segment have this nominal data type client, which says, or do we have like clients in this specific segment? We say yes, in governments no, corporations yes, middle market yes. What we can do, we can like count of these client answers, yeah, and get the data, making this data to numerical data. This is possible, yeah, but we can see that the clients yes and no doesn't mean like numbers. And so this data cannot be quantified, yeah, to sum up, divide, multiply, subtract, and these mathematical operations cannot be used in these types because it's usually defined by text, and we know the text could not be used in mathematical operations. And if we go deeper in these nominal categories, we have 3 big categories underneath. The first one is nominal data with the order. For example, this means the data has specific order, which we know or we can build by by ourselves. I have here like temperature in the office, you know, the cold temperature is like 15 degrees Celsius. Normal is around 20, 22 degrees. Warm is 23 plus till 27. Then the hot is like plus 27 degrees and over it. And this is like nominal data. We can see it's cold, normal, warm, hot. For example, yeah, on a dashboard or a screen. And this is like specific order which we can build. The second is Thomas data, yeah, really tough word to pronounce. Sorry if I didn't correct it. This is like data when I only have like two options. Like usually we go on the internet on some kind of web pages, and they are like asking, "Hey, we care about your privacy. Do you want to allow us your cookies, use cookies or not?" And they are like providing two options: consent or dissent. I agree or disagree. Yeah, it's like yes, no, black, white. Only two options we can use. The second and the last thing is nominal data without an order. For example, I have my clients. I am the government, and I have all the citizens in my country which have flight in last 24 hours, and I see all the citizenships of them. And there is no meaning that the Germans are first or like Turkish are last. In these data, yeah, we have no specific order, and it's just like describing in this example the citizens who have fly to the Latvia. And the second category of the qualitative data is ordinal data. This means the data has a specific order, and usually it's ranked. And when we are ranking the data, there is no specific information that specifies or differentiates these categories from each other. And this means when we are building ranks, there is no differentiation. Like yeah, and you could not like use some mathematical operations when we are building um, these ranks. Yeah, like a small example of runners in the run, and we have like places, and it doesn't mean like anything if we like 4 times 2 and we have the 8th place. No, it's not even possible. And this like rank just only show the visual cue how the elements are like placed in specific order. And when we are talking about these data, what we can do with data, the first thing we can like describe it. And we know this descriptive statistics option. It's really easy to use in Excel. Just add an analysis toolpack from Comma-Dins, and you have it. But in Power BI, it's a little bit trickier to have these descriptive statistics. And here I show you that in Power Query, using the formula table.profile, you can build this descriptive statistics for your data. Over there, I have in this image descriptive statistics of I don't remember of is it crude oil or natural gas prices, but you can see we can build min max, average counts and distinct counts. And so yeah, this is like the options that you can use in Power BI. And this also, well, it's like great starting point to understand what your data has and how wide it and what you can do with it. And this data could be also descriptive statistics put inside in the tables and graphs. And then we see, oh, we have a lot of like the values or not so many values. And not without description, data could not have any explanation. So the next thing, we can count the frequency of the data. It's we know that this is really useful for this qualitative data when we need to like count the times which variables exist in data set. For example, I have here the qualification of education. I have like students, like students but employees and with their education, but you cannot like count this employees. I can count their education, and you count it in the table, and then you can draw the summary inside the chart or in table. So, but these summaries are really useful. But to understand a little bit more deeper, we need to use informational statistics. And the statistics, this statistic type is really interesting, and it's called, why we are using it, we can develop from it hypotheses from the data set and make some kind of generalizations, predictions of wider sample groups, and what we have and what we don't have. And For example, in on this weekend in Latvia is happening municipality elections everywhere around the country except Riga, and usually before the elections, yeah, they are like walking around and like asking, like predicting who will be the winner, and using the small batch size of these citizens who elect, they can like predict, yeah, in this municipality will win like party X or like party Y, and using this like hypothesis, small data sets, sample sizes, and you can like make some kind of generalizations and predictions. But I'm really like concerned about this thing. Yeah, it's really good if we need to like to understand a small part of the big these whole data set, but you cannot draw a perfect conclusion of from them. So you need to like be critical and argument and to seek deeper. And finally, when we are like talking about the data, well, at the end of the day, we need to some kind of like put the information, these zeros and ones inside the visual of these representation. And the best representation is usually based and determined by the data analyst and what he want to like say and send a message to these the users of the reports, for example, yeah, and we can like ask if we are like working with the business data, like what I want to like show. Maybe I can like show some kind of trends we have. Yeah, we are like really great sales, and the new product is like going well. So kind of like I show the trend. If we like sell more this new product, we can like generate more leads. Or maybe I just want to show that how the company has developed over the time, over the last 6 to 8 months, or different variables going together in one chart and like showing them, or just like we have some kind of outliers in our data set and we need to like ask ourselves, well, why it has happened, and is it good or is it bad? And when we are like sending these quantitative messages, it's really nice to think about these types we can like send. The first one is like nominal comparison, that there's no particular order, they are just individually compared. For example, we have these segments, and these segments have specific sales amount, and we are just like comparing in the bar charts. So for this kind of message, we have the bar charts, the best visual. The next is time series, period over time, months, days, years, quarters. For this, just use the line chart in Power BI. The next is part of the whole. It's ratio over the whole. In this time, you use this, how to say, not so well in the data visualization world, favorable chart, pie charts, and then donut charts. Yeah, they are like really tricky. If you know how to read them, and how to communicate through them, sure thing, just use. If not, then try to use other one like bar charts or column charts. And the next one for ranking, can use like tables. It's really easy. Tables with conditional formatting, like in matrices in Power BI. Then deviation. It's like we have some kind of zero value point, and from them how or like sales or temperature outside in the cities like happening. And for frequency, we are usually showing the data in histograms. It's not like standard visual in Power BI. You need to like import it from the store. Also for the frequency, you can like use the histogram and box and whiskers plot, popular in the statistics world. And finally, there's correlation. And we compare two measures, calculating the R value. But as I'm always saying about correlation is not causation. So be careful when you are using it and when you are communicating with other these stakeholders. And finally, what I want you to show when you're talking about the data, it's also great to read some statistics books. They are not die-hard statistic books, which you read in university time, about these formulas, how to use them, and really like not so interesting examples. The British great this Royal Statistics director and board of the member, David Spiegelhalter, wrote this fantastic book, The Art of Statistics. I'm really grateful for this book. Because it gave me a lot of insights, what to think about data and the relationship between us. So it's not always what I'm thinking, it's really happening. So just go and grab this David book. It's really great. Also, the Old But Gold book, yeah, Naked Statistics by Charles Whelan. It's just brilliant. Also, Alberto Cairo is suggesting it, so grab it also, this copy. And finally, Edward Tufte, when he's showing this visual display of quantitative information through all the times which we have of graphicacy. Really great book. See the examples and ask yourself when you're reading it, am I understanding it correctly? What the author just wanted to show me? And I just went through all these like data types: descriptive, nominal, ratio, order, and ordinal. But it's really hard to like remember from this one presentation. So I can share a really nice two links where you can like ask yourself, I have, for example, numeric data and what I should like use. And here are like two links, data to viz and data with catalog. And right now I will like show you the demo of them. So first of all, yeah, is data to viz. I will post it in the chat, this link. So you can like grab it and go there. And then I'm saying explore, and I go there, and we have this tree chart. Yeah, I'm saying I have numeric data, but I have like two numeric variables, which is not ordered and have many points. So they are suggesting me, hey, let's use this violin plot. I say, okay, what is violin plot? It's saying it's green, just brief introduction, what violin plot is, how to use it, where it came from, and usually that's the common mistakes when you're using it. So it's really great. And also, if you are like a more code person, you can like import it and use it in the R, Python, or 3GS. Also, for example, I have categoric data with one categorical variable, and you are like going over it, you see what is one categorical variable. If I go two or more, it doesn't show anything. Okay, here we have nested variables, subgroup variables, agencies, independent, and I can see what we can use. And also, if we are like want to see what kind of the just overall graphic types we have, you can say distribution data. For distribution, you can use this. Part of the whole, use tree maps, donut charts, pie charts. For the flow charts, you hoard networks, Sankey's. For correlations, scatters, heat maps, and you name it. Just yeah, I think it's really great website I found by myself, and so just use it. I'm just sharing briefly. Yeah, you can see also what's the like common mistakes of different types of charts when we are using it. And also you can like buy this beautiful poster. But getting back to the second page, I'll share also this in the chat. So the second page is this catalog where you can see also these charts, but more different. Let's say search by the function. I say, what do you want to show? Yeah, I need to see like location. For example, I say location, hey, use for location these charts. Okay, I want to just view the list of kind of type we have. Yeah, graphs, plots, like population pyramids, radar charts, diagrams, like tables, other charts, maps. So it's also a great resource when you can use this data, how to visualize data, and and work fit. So, but my favorite is this because it's like in beautiful this chart, like tree map, and you can like see it really briefly. So that's all from my part. Do you have any like questions or comments?
Yes, thank you, Emil. So now we give you brief but not very short introduction into data literacy. So maybe you have something to share with others, your opinion or your view on data literacy. Importance of data literacy. Yeah, no worries if no one wants something to say, that's also okay. Yeah, so we will provide recording of this meetup. So thanks everyone for coming. And I wish you a nice evening and see you then on next meetups. Okay, have a nice evening. Thank you. Bye.
Bye.